Hi everyone, this is Jaser. It's been a long time since I last posted something on YouTube. This video is about React source code walkthrough. It's episode 25, and it's about suspense list. This component, suspense list, it's on the React official homepage, but it's not officially released yet. It's still under experimental flag. Yeah, I've spent some time to understand how it works, and it's very interesting. Though I'm not sure that I can explain it well. I hope that after watching this video, you would understand that the general picture of how suspense list works. So these the materials already on my blog. It's jaser.dev. If you're interested to reading through the text, you can follow it there. Yeah. So first, let's understand what it is, right? It's on the official homepage. It says it is a way to orchestrate the revealing order, or how you want to a list of suspense to render. Here's a basic example. So this is, we put three suspense together, but without suspense list. You can see, let's click start. You can see that order, because we have three promises. The second one is resolved sooner. It will be revealed sooner, right? First 2, 1, 3. This is not optimal. Personally, I don't find it any problem to me, but maybe from a user perspective, it's kind of weird, right? We have an order from top to bottom, but we render something in the middle. There's basically no ordering, because this is how suspense works, as we explained in the previous video. When the suspense, when something is suspended here, it will find the closest suspense boundary, which is here, and then attach the promise then listener. So when it is settled, this one will try to re-render it again. But the other way, for the second one, it's resolved sooner, so this will be revealed sooner. So this is the default behavior. We don't want this. That's why we try to add the suspense list and say, okay, we need to reveal it with the order of forward, meaning we need to render it from top to bottom, left to right, basically the order of how the elements are. So even though we have the same promises here, even although the second promise is resolved sooner, we can see that result that it will not, okay, the demo is here, it will not be revealed sooner. You can see it will be revealed together with the JSR1 because we need to render this first. When it is revealed, because this promise is already resolved, we can just so from our eye, it's just the render together. So by this, we kept the order, so it's no longer weird to the users. So this is, and there are some other property on suspense list we will skip for now. Basically, they have the same mental model. So yeah, this is suspense list. You can think of like an higher order component that orchestrates how suspense works. So how do it works? This is interesting. So by default, this is long list. Let's just hang on. For these two, by default, they just render by themselves, right? When it is resolved, we just try to reveal themselves. But when we put together, we have some extra information to pass on to these individual suspenses. So there becomes this question: how to check and pass information from siblings? Theoretically, there's some information to resource 2, right? Say, okay, I'm ready to re-render, but something told me that the resource 1 is not yet, so I have to wait. But because they're siblings, basically we're not able to pass on information to siblings, right? If you are not sure, let's go to our algorithm. I think there's a Travis. Yeah. You can see this tree structure, fiber tree structure. It's just a child, sibling, and child, sibling. you cannot get for 4 you can get some information from 5 maybe, but from 5 you cannot get some information from 4 because there's no reference. The tree structure is like a linked list. You can see child, sibling, and return. So for 5, if you want to pass on some information from 4 to 5, it's impossible unless you pass it from context, which means you set the information to 2 and then pass on to 5. This is why in usual web the state management, if we don't use Redux, any state management library, you can use context, right? We can use context to hoist the state to a parent and then pass it down to the descendant. So, it's basically you need to do the store the information in the higher order component. Okay, in the previous post about how Suspense works, we had this piece of code, which means that when the Suspense is updated, this function is acting. It's used in the initial render as well. There is a code here you can see. Show fallback. This determines whether we reveal or not. So default is false, and then we catch if some error, the promise is thrown in the descendant. This flag will be set, and see if we catch some error, catch some promise, and then we will set it to true. But there's another condition that we ignored at this time, is that should remain on fallback. So this is through the Suspense context. I can think that actually the Suspense actually gets some information from the data structure called Suspense context. And even though the promise is resolved, that this Suspense is false, but this will remain true, so it will still show fallback. This is the true, I think this is the key pieces on Suspense, how the Suspense list works. So for the second Suspense, even though it's ready, so this Suspense is false, but somehow the Suspense context gives it this information that you should remain on fallback. So, and it will remain on fallback. So this context must be some dynamic value that when the first resource, the first Suspense is suspended, it will be set to okay, so let's go to this picture. So the first Suspense, when it's suspended, and the context will be you should stay on fallback, and then go to second Suspense. Even though it's ready, it will get the information from its parent, the context, so it will remain on fallback. Cool. So what is Suspense context? So this is interesting. This is the first time I ran into some extra internals of React. If you take a look at the code, it's not complicated. It's just basically it's React fiber stack. You can think of like keeping the path to the fiber. So for 3, the context is 1, 2, 3, right? For 4, the context is 1, 2, 4. For 7, the context is 1, 2, 4, 7. So the context, you can think of the context is basically all the information you need or you can get from the root to yourself. So all the fiber nodes along your path. The React fiber stack is a way of is the implementation. So there's a method called pop and push, and then it will set the value stack, put the value on the value stack. So every context, I think even the default context is using this one, I think. For Suspense context, you can see that basically just a wrapper on this React fiber stack. One thing to note is that because every kind of context is using the same value stack, we must be very careful that the push and pop are well coordinated, right? So when you go to 2, you must push it. When you complete it, you go back to 1. You go to its return, which is 1. Then you must pop it. Otherwise, it will not be consistent. You might get some value that you don't want because we're using the same stack to hold all the context value. So this is the suspense context. And here's the question. When a push suspense context called? Yeah, this is pretty straightforward. When we meet some suspense or suspense list, we would push the context. If you search through the source code, it will be in update suspense component, update suspense list component, and some other internal functions. We will skip them. When it is popped, complete work. When it's complete, we should pop. When it goes to the sibling, we should pop it because the path to the fiber are changed. Some other unwind work I'm not familiar with it yet. We can skip it for now. So suspense contexting update suspense component. So in the update suspense component, we can see that this one, suspense context, we get to the suspense, the current from suspense stack cursor. This is just the internal implementation. You don't need to worry. Suspense context is set default shadow suspense context, so it's kind of shadow copying the context and pass it along. Push context, it doesn't matter that much. The one thing you need to worry is that you can see here, it's called force suspense fallback. There are 2 digits on the context. One is lower, the higher one is force suspense fallback. This one actually means that for 4, when you go to 4, the suspense context, if it is the force, if this one is true, the higher bit is true, then it should stay on fallback. So this is how the suspense context work. How to do passes. So this is some question we don't need to work. It's kind of related, but let's just bring these questions to ourselves. In the suspense reconciliation, we notice we mentioned that there are 2 passes rendering how suspense handle exception, right? So the first one is it will render itself because suspense knows nothing. It will go down to this content, and while there, it will catch the exception, and it will go up straight to the nearest suspense boundary, set the flag, and render the suspense again. And this time, because the state is changed, internal state of suspense changed, it will render the fallback instead. So it's kind of like if else there. This is an example of how we do some strange logic or like a branching logic inside of tree. So basically, you can create a special component and it have some special state, and then this component will render differently based on the state, and then we can change the state based on the rendering phase, right? We have begin work, and then we have complete work. And interesting thing is that because of the tree structure, it actually has all the information about the child, the descendant node, and you can begin work when you begin work on this 4, you can actually traverse through all the subtree and get the information you want, and you set the state, and then do everything you want basically. The traverse tree, I think we can skip this one. So the traverse algorithm is begin work. If there's begin work means that do some work on yourself and its children. So it will go DFS, go to child, and begin work, go to child, begin work. If there's no child, there's no work, it will start complete. So complete work. When it is complete, it means that, okay, either we go to sibling or go to return, which is the parent. So go to sibling, and then begin work on it again, child, and then go to sibling. Okay, complete sibling, do work, child, do work, and then complete. And there's no sibling, so you'd go return, which is 7, return, and 7, 4, 5, 2, 1. So 1, 2, 3, 4, 6, 7, 8, 7, 4, 5, 2, 1. So this is the basic algorithm. Get familiar with it. So here's a question. How can we keep rendering a component forever? So in complete work, if in complete work, if there is sibling, we go to sibling. If there's nothing, we go to return, right? The parent, right? But in suspense, actually, we've already seen this trick. Is that when it's complete, we set the work in progress to itself, so it will begin work on itself again. So basically, in complete work, if we don't go to the return. We set the work in progress to itself, and then you begin work, complete work, and begin work. So it will render in a component forever in this component. How to render the component in n times? Well, this is similar to the first question. We can just keep the internal state of how many times it is rendered, and that will just check if the maximum is surpassed or not. If it is still have time to render, we just keep rendering. How to connect info from children and pass it on to other children. So this is interesting. First, we can render all the children and expose the necessary information on fibers. Yeah. And then we need also a way to interrupt the rendering so that the control can go back to the component. Yeah, because suppose like for the component here, you want something, some strange logic based on these children. If we just go to render complete, it will just go to sibling and go to 1, right? So yeah, we need some special trick that you need to interrupt. Somehow, when you get the information, you need to go to 4 again, and then render the subtree again. After being interrupted, we can now traverse through the children again and collect the info. And this is just traversing to collect, not for rendering. Sorry, I'm a bit confused what I wrote here. Okay, oh yeah, sorry. The 2 is actually a hint for step 3. And then we update the context where info we need, and then we render the child fiber again. So we set it in the context so that all the subtree knows some information, and you can do it to render again. Yeah, so it's like 3 passes, right? The first, we render them and have enough information, like suspense, if it is suspended or not. And then you can do it again, like when it is complete, you do it, check the state again. So this is collect phase. We can traverse through the subtree and connect information and set it to the state of itself, internal state. And then the third one, not because the context is updated, you can render it again. So now subtree will change accordingly. So this is the basic idea. It's very convoluted, I would say. Suspense context in suspense list component. Yeah, this is the piece of code, but we don't see any thing strange here. It actually basically just pass on the suspense context it has. We need to find it out where the forward suspense fallback is set. So actually the question is answered just right after this piece of code. So this is it. So we can see there's a switch based on the review order, forwards, backwards, together, something. We just focus on the forwards. Yeah. So, okay, this is very tricky about how suspense works. I'll explain it, try my best to explain it. So basically, the first one, the last content row is find the last content row. You can think of like find the last row among these children that is already showing content on the screen, as opposed to being a fallback. So basically, like for here, content, fallback, content, fallback. This is how the children will be, right? Maybe. So it will find the last content, which means that the end of content and the first fallback is the tail. So the idea is split the children into 2 lists. The first one is content that we can safely reconcile and render them. The second, the fallbacks is that something we want to render in a specific way. So find the last content and set that this is the tail. If it is now, it means that there's no content, so everything is tail. And we would, this one is interesting. We'll cover it later. And if we find the tail, we set the tail, is the next sibling, and sets the last content row siblings to now. Okay, and then we set the initial state of about the suspense list. So here is very interesting is that when we reconcile a suspense list, we detach the child if there is all the tail, and also if we detach remove the sibling relation from the content to tail, we actually need to split. Remember our graph here, like even though we find the tail content here, this one is tail, this is a sibling right here. So when you reconcile 3, reconcile 4, when it's ready, it will actually naturally go to 5. This we don't want that. We want to have the suspense list take control of the render of the tails. So we need to remove this sibling. That's why you can see the sibling is set to null. And if everything is tail, the first 3 is tail, it will set the child to null. So there's no child. So basically you can think the tails will be fully controlled by suspense list. Cool. Yep. Yeah, you can see what kind of state is stored in suspense list. There are some flags, basically, the configuration. Yeah, nothing fancy. So the magic lies in complete work of suspense list. So when it is completed, you can see, okay, this is a huge chunk of code. We finally find that the force suspense fallback is set here actually. Let's break it down. Okay, so here is something, okay, I've already forgot what it is, but render state is configuration, is internal state of suspense list. If there's nothing, it means we don't need to worry anything. So suspense is return now. Return now means it's complete. So it will actually go to its parent. Because into the complete phase, all the subtree is already completed. Suspense list also has a did capture flag because in forward there's a revealing order required. So once suspense list finds the first suspense did suspense, it will use the same promise to trigger and update the did suspense already. Could use to avoid using upcoming promises. Yeah, this is true. You need the flag to store the first promise. Yeah, indicate the first promise. Okay, here, skip all the detail. We can see this one is very important. We can see that, okay, we need to complete. You said if the tail is not now, we need to render the tail, right? So we get the tail, and then we set the rendering to this tail, so we start rendering it, and set the tail to the next one, and sibling to now. This is very interesting. It means that suspense list will detach, split all the tails one by one, and then render them separately. You see, the tail is rolling forward by one, and the old tail is isolated by removing its sibling. So when it's complete, it will go to this suspense list again. We will have a graph in the end, diagram in the end, so no worries. So here you only need to know that the tails, all the tails of the suspense list will be rendered one by one. It's not, and render one, go back to complete work of suspense list and go to next one, yeah, and then it will finally be processed. Okay, so here are some other piece of code. I'll skip them. What roughly it does is find the suspense and connect the promise, yeah, and sets the for suspense fallback in the suspense context, yeah. We render the whole list after we set child fibers, which reverts the splitting. This is because during our rendering suspense list, we see that we detach the child, detach the sibling. It will make the tree structure inconsistent, right? So next time when we are rendering here, okay, wait, where is it? There is a reset child fibers. This function will just reset, yeah, as it says, resets the child, resets the sibling, so the tree could be consistent. Okay, where does this code go? omitted code. Where is the omitted code? Here. Okay, here. Rendering if the tail is now, we just render the head, and otherwise we render the tail. Right after we split the context. So we render the head and we render the tail. Okay, we just render the head, and then if it is not suspended and blah 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 blah, there is reset child fibers. We render the whole list, but this time we will force fallbacks to stay in place. Reset the effect by before blah blah blah. Okay. Sorry if I'm not clear or something. That's just because I'm not familiar with totally understanding it. I'm trying my best. Cool. Why we're re-rendering the whole list again? I'm guessing that since we are reconciling, the other promises might already get fulfilled. If we don't force everything to render fallbacks at the beginning. Oh, I see. So why we are force rendering fallbacks at the beginning? That's because we need to. The initial stage is not assured, right? Because the reconciliation takes time. If we try to understand 3 and it is already resolved, then even we set the forward in the suspense list, the order will not be kept. So that's why we need to render all fallbacks at the beginning. So this is not meaning that it will render something to the user. It's just like a totally solid initial state for the reconciliation to work. For the other branch of second pass, we don't have the need to re-render again. Yeah. Blah, blah, blah. Okay. Quite some details. I'll skip it now. Yeah, so let's summarize. I'm not sure whether you understand it. I don't think I explained it pretty well because I'm not like 100% sure about what is going on. This is my best guess. So when we update the suspense list, it will first split the children into 2 lists, head and tail. Head means safe to render, no suspense. And by searching the last content row, not suspended suspense, it's the last content row. So because the children, as we put in our example, it might be something other than suspense, right? It could be some ordinary dev, something. Yeah, and then suspense head is rendered as normal, and when it's complete, it will go to suspense list. Suspense list renders the tails one by one in complete work. So it will disconnect each of them, renders the first tail, complete again, and go to the second one, complete again. So it checks for the first suspended suspense and set up the retry listeners and sets the fallback in the context. So the suspense coming process later, they will render fallback no matter what the state is for their promise. So here's the problem. Why popping the tails one by one in the second path? I'm not sure. This is a very good question. Why not just render them all? Right? Wait a minute. Why I ask this question? The algorithm, why do them one by one? Literally, when we complete here, when it is suspended, we need to update. Okay, yeah. I think this is not right. The reason I put it here is that because if we are all rendering fallbacks, it will be pretty quick to finish. But if we're rendering subtree, stuff like that, it will cost us some time. And in that time, things might change, right? So this is why I said it's rendered one by one. The other thing is that I think if we're not rendering one by one, oh yeah, so the question is here. Why don't we yeah, this is it. So why don't we only go complete the suspense and go to suspense list when it's suspended. Otherwise, we could just keep go to sibling, right? So this, other than this, it's just the steps are unnecessary. So the answer is that because we're rendering kind of multiple subtree, it's gonna take us some time, possibly. So because of the concurrent mode, it could be interrupted and resume sometime later. In that case, we need to keep the state, right? So so the idea is that it will try to keep the work like split the work into small fractions, and so that the suspense list could keep track of the state. Later, when it's resumed, it could be able to find the last time it finished and then continue. So yeah. So I think the question about going back to suspense list is already answered, because we need to pass some data into the suspense context. We at least we need to go back to suspense list once when we find the first suspended suspense, right? The questions of why we are actually doing it one by one, even though they are not, we don't need to handle. It's because I think we need to, basically I think we need to make the work unit small as possible. So this is the basic explanation. In the end, let's see some diagrams to see how it really works. So we have suspense. The first one is a p tag, and sibling suspense 1, suspense 2, suspense 3. So now we're going to render, right? So begin work. At the beginning, we're just to start reconcile suspense list. In the initial step, no content row is found. New fibers are not counted here. So in initial step, there's everything is tail. So tail is set to div. The child is removed. You can see is removed. I use this like a dotted line because it's not actually in the tree structure. You can see from the tree, it's only suspense list. Everything is like moved in another document fragment. It's put it somewhere. So the tree is has only suspense list. So now we'll begin work on suspense list. Because there's no child, it will complete itself. Since child is now, we start to render. The complete work was kick in. It was child try to render the tail. So as we said, to render the tail one by one, we will remove the sibling here, and then also set the child. So we will begin work on dev. Because there's no children, we'll complete work. There's no sibling here, it will complete suspense list again. And then we will repeat this process. It will render the suspense and render suspense 2 and suspense 3. Now, after render suspense 3, the last content row is suspense 3. Because this is the initial state, we haven't go to child yet. There's no exception, there's no suspension. So, and then it will go to, and this, after button is clicked, we have this suspense, right? So, the suspense here is actually rendering nothing. If you look at our code here, resources empty, and in your child, it just render nothing. So after the button is clicked, promise started kicks in, we begin work again. Now we have the child, we completed, begin work, and we complete it and begin work. Because this is last content row. These are still be treated as head. And the sibling begin work, and then now it's because there's exception render fallback. I put a dotted line here because this is not the true tree structure. If you go to our previous post about the internal structure of suspense, there is off-screen component. So this is like an abstract indication. We go to sibling, begin work, blah, blah, blah. So finally, all fallbacks are rendered and complete go to suspense list. Eventually, all suspense fallbacks are rendered and complete work works on suspense list. And it will, since now suspense list is possible to suspend, it will search the children and found a suspense list, a suspended suspense. So did capture is set, and the context is here. And it goes to the next suspense, but since there, all suspense render fallbacks without deeper check. So everything will be in fallback and complete. Eventually, complete is called again on suspense list. There's no tail. There's no tail to render, so it is done. I'm a little confused here, but generally the idea. So when the second promise is fulfilled, re-render kicks in, begin work. Now this is child, this is tail, and then the process similar before. First, the flags, the context are reset. Tail is set to the first suspended context, suspense, and the head is disconnected from tail. So begin work, complete work. First suspense div is worked on, and prepare to render the tails. The suspense one, go to the first suspense, and go to the first suspense. Complete work will kicks in, and this time, since there is tail waiting to be rendered, suspense list searches children and found the first suspense is suspended, so the flags are set again. So the context, and when we render suspense, even though the promise is fulfilled, it still renders fallbacks because of the context. So this same goes for suspense 3. And when the first promise is resolved, we'll just repeat the process, and this time it will render itself, and suspense 2 is already fulfilled, so we render and go to suspense 3. And the process, it is, the context is set again. Okay, that's it. It's pretty complex. I don't think I had a great explanation, but anyway, the one thing that I want, the one takeaway from this video is that, remember, here, this is basically, I think it's easier to understand. So when the suspended list is rendered, it actually will detach itself, put it into, put it off from the fiber tree, so that the suspense list could have full control of the tails. And basically, it will render the tail one by one, and in that rendering, it could have some information in its context for its descendant to render. So this is basically the idea. I put this diagram so that in the future I could create a visualizer, but I'm not sure. I'm not sure whether it's possible. But anyway, suspense list is pretty interesting. It's kind of like a niche knowledge. Maybe in the most of the time you don't need it. Still, yeah. Why don't we just have one suspense for all, right? Well, it's not cool. We actually want to render things when it is ready as soon as possible. But this is just some balance between the developer experience and the user experience. Cool. I hope it helped. See you next time. Bye bye.